Thank you very much for staying so long with us, and thanks to the organizers for inviting me to this most interesting conference. I think it's the first time that I'm invited to a conference where there are artists, scientists, policymakers, business people all together to discuss these interesting issues. Don't be surprised if you see some resemblance on some slides to the previous speaker. That's simply because we act in the same legal framework, which is the European Patent Convention. As you heard, I'm at the European Patent Office as a patent examiner, so I see the applications coming to my desk. I have to decide if it's patentable or not. I have also been involved in some extra activities over the last years, and that's probably the reason that I'm here. At the European Patent Office, we have devised some scenarios for the future where we develop thoughts about how intellectual property could look like in 2025, and that's why I found the Gaia Corporation very intriguing and very interesting. It resembles at least one of our scenarios a little bit. Let's see if I deal with the technology here. I wanted to step back a little bit. When we talk about owning life, of course you have to think about what means owning, and you have to think about what property is. And this is just the definition of traditional principles of property, and actually that pretty much applies also to intellectual property. It says when you own something, you can control the use of it. You can, for example, forbid someone to step on your ground. You can own the benefits from your property. If you have a forest, you can cut down the trees and sell them or whatever. You have the right to transfer or sell the property. You can inherit it to your kids or sell it away. And you have the right to exclude others from your property. So that you will see in some cases is identical for intellectual property, for other aspects, physical property and intellectual property have some differences. Then what kind of forms of properties do we find? The major distinction is between tangible and intangible property. Property that you can touch and property that you can't. In the tangible area, we have immovable goods and we have movable goods. And you see, and it's highlighted in red here, in all these areas, you find some property on what you could call life. In the tangible area, you have property on forests, you have property on plants, animals. You have also, of course, man-made plants and animals, and nowadays transgenic organisms, synthetic organisms. Then when you come to the intangible part, you have financial instruments, and there you have options. Options on crops, options on farm animals, and then you come to the big part of intellectual property, which is also an intangible form of property, with patents, copyrights, design rights, and so on. Living things are patentable in many jurisdictions in the world: US, Japan, China, Korea, and Europe. And I will come a little bit to the details, and some of it we've heard already from Philip before. So as alluded to this, what is a patent? It grants the patent holder the right to exclude others from using his invention. It's not a right to practice the invention. Often, and that's the difference to physical property, often you have overlapping rights. When you own a part of land, you normally can be sure that somebody else doesn't own that part of land. With intellectual property, you can never be so sure, because intellectual property, and patents especially, often overlap. You have broader patents which cover more narrow patents. Sometimes there are third and fourth layers of even narrower patents. And sometimes you have also in one single item, like a mobile phone, you have hundreds, sometimes thousands of different patent rights in it. So for one single item, you might need to ask many right holders for licenses. And that's also different to physical property, protection is granted for a limited period of time, 20 years usually, and for a specific geographic area. If you have a European patent, it doesn't mean you have protection in the US, and we heard the example of Argentina and Europe. So that also is a difference, because if you own a pet, you can take it wherever you want, you will still be the owner. You can also you will also be the owner if the patent gets older than 20 years. Why patents? And we heard this with some good examples from the University of Ghent Tech Transfer Office. Doing the innovation is often not so much the problem. The problem is bringing then a product to the market, to having the security and having the incentive to invest into the development of a marketable product. And for this, patents have been shown over the last few hundred years, because they have been invented already in the 14th, 15th century, to be quite an effective tool. They also prevent secrecy, because once you file for a patent, it has to be published in 18 months, and you have to tell everybody how your invention works. Thus, it can avoid duplication of research and development. People can look if their invention is already there, or if they really want to go in a certain direction. And what becomes also more and more important is patents give a tradable right in knowledge goods. You can go on auctions nowadays and sell your patents. There are stock market trading of patents, and there's all kind of ways to find people who might invest in your invention. You can only get a patent if it's non-obvious, so you cannot get patents for trivial incremental inventions. Industrial applicable, which means it should be usable in some kind of industry, including agriculture. And there are other criteria like sufficiency of disclosure, which has to do with the description how you work the invention, so everybody should be able to work the invention based on your application. Patents on life, if you want to call it like that, or on living organisms, are actually not such a new thing. I researched a little bit, and the earliest thing I could find in the publication was patents from the 18th century on yeast. And that has gone on over the years. There is a famous patent for Pasteur from the year 1873. And then in the 20th century, it really took off, one can say. There is a Plant Patent Act in the US, which allowed patenting of plants. And there's a famous Supreme Court decision, Diamond versus Chakrabarty from 1980 in the US, again, where it was found that a genetically engineered bacterium can be patented. Furthermore, the Oncomouse, has been mentioned already, was patented in the US. In Europe, it took a bit longer. It went a bit back and forward between grant and refusal and opposition and appeal, but finally it was also granted. You see it down there in 2004. In between, we have the European Directive on the patentability or protection of biotechnological inventions. And this directive, which is now also implemented into the European Patent Convention, clearly says that plants, animals, microorganisms are patentable. Now, where are we moving? I put down there, and this is actually an image of this nice Cynthia Craig-Venter's minimal genome bacterium. There are patent applications pending, and I checked again, and I couldn't find anything that was already granted. So apparently the examination is ongoing, and it's still out if there will be a patent granted. Because of course, again, the criteria of novelty, inventive step, and so on have to be applied. As you will see in a minute, I don't think there are any specific patentability criteria applying to synthetic biology. I think it's the same criteria that apply to all biotechnological inventions. Short definition. For me, I have worked in the lab for some years, but now I'm out of the lab since a couple of years. It's a bit difficult actually still to grasp what the difference is between classical genetic engineering and synthetic biology. And we have heard this also today. Probably the most clear distinction is the approach, that it's not so much anymore a scientific approach who wants to understand, but it's more a designing approach. And that's what's also stated here. Engineering applied at all levels of hierarchy, and the aim is to design biological systems in a rational and systematic way. As we also heard earlier, we are probably most likely not there for a number of years to come. In today's work on synthetic biology, we're still based on biological systems, and this will continue to go on like that for a number of years, and that's also the reason that in terms of patents, I cannot see a major difference. Because if you compare, in a way, it's an incremental change. We go from focus on a few genes to many genes, from scientific to engineering, from non-standardized to standardized. And there are also difficulties with this. The standardization is not always easy because these systems are so complex. Biological to chemical synthesis. So what's the difference between modified and artificial life? You have seen these provisions, all the things that are excluded. I put some other examples, bioweapons, an animal variety like the Holstein cow. We had recent case law on essentially biological processes, so breeding based on crossing and selection. This is excluded, so breeders' technologies cannot be patented. And you have heard about the exclusion of treatment methods for the human and animal body. And this you have also seen already. There are some specific exceptions. This list is not exhaustive. It's just the few examples that the legislature has given of examples which at that time the European Parliament wanted to exclude explicitly from patentability: cloning of human beings, modifying the human germline, the human embryos, use, and these animals which suffer without a major medical benefit. And this is the list of what is patented. And here, again, I also want to focus on the point that although, for example, genes and proteins which are already present in nature, although they exist already in nature, they can be patented because they are isolated and they are made available. This is a kind of a legal fiction because the legislator found that a gene in the body is not really accessible to any technical treatment, and if you isolate it and if you make it available, then it can become patentable. Plants and animals are patentable, microorganisms, and sequences isolated from the human body. The important exception is the human body itself. It's not patentable at all stages of development, so also embryos, fetuses, and so on. And the simple discovery of a gene. So simply sequencing a gene and writing down the sequence is not enough to obtain a patent. You have to give a function. This function can be the biological function, like I've shown here, gene translated into mRNA, translated into mRNA, translated into protein, and the protein has a function. If you can find this out, that's a way. But it can also be a function, for example, in a diagnostic kit, or another function that is useful and that is specific to the sequence. And that has to be described in the patent application. So back to the question, what is owning life? And in connection to what I said in the beginning about property, I think there are many instances where you could think if someone is owning life, this can be related to patents, and I've listed some examples: patents on gene sequences, patents on transgenic crops. But of course, there are also people who own physically living things: farmers, scientists, universities, and then there are investors who have certain options, certain property on living things, sometimes in quite a big scale. But there are other instances where life is left to the realm of the public commons. And an important statement here is the UNESCO Universal Declaration on the Human Genome. where you find that the human genome as a whole is the heritage of humanity and should not give rise to financial gains. So this is excluded and this is deliberately put into the public commons. And there are other examples, especially databases, but also public seed banks, stem cell banks, where either the regulator or the scientists themselves felt that things should be left in the public. And I think in general, for this question to decide if it's useful or not, or if you should have ownership or property in these areas, it's important to ask what for, and to ask what is the benefit. In some areas where investment in a technology is really high and copying is very easy, patents or intellectual property can be very helpful to stimulate this investment and to bring product to market. In other areas, like basic research, it can be more advisable to leave things in the public and to foster an open and collaborative approach to innovation. But I think this discussion is also still ongoing, and we have, I think, between the patent profession and the patent offices, but also the licensing agencies and regulators and politicians, we have still discussions about how to find the best balance between public and private property. With this, I thank you for your attention.